We are about to show you the telescope that is literally breaking science. In this video, you'll find out how the James Webb Space Telescope found galaxies that physically should not exist, how a Nobel Prize winning physicist stood in front of the world and said our understanding of the universe may be completely wrong. All of this is real. All of it happened in the last 2 years, and all of it points to one terrifying conclusion. We may have had the universe completely wrong this entire time. First, what even is the James Webb Space Telescope, and why does everyone keep losing their minds over it? See, for decades, scientists had a problem. The universe is old, like 13.8 billion years old, and the light from the very first galaxies, the ones that formed just a few 100 million years after the Big Bang, had been traveling through space for so long that by the time it reached us, it had stretched way beyond what the human eye or even older telescopes could detect. It had shifted all the way into infrared light, basically invisible. So NASA, ESA, and the Canadian Space Agency spent 25 years and $10 billion building a telescope specifically designed to see that infrared light. They folded a mirror the size of a tennis court, launched it into space on Christmas Day 2021, and pointed it at the darkest patches of sky imaginable. And what they found was not what anyone expected. Here's where things get wild. Because when astronomers got their first real look at the early universe through Webb, they were expecting to find small baby galaxies, tiny little proto-galaxies barely getting started, just beginning to form their first stars. That's what the standard model of cosmology, the rulebook of how the universe works built over decades, predicted they'd find. Instead, they found monsters. Webb kept spotting galaxies that were enormous, fully formed, bright, massive, and they existed just 500 to 700 million years after the Big Bang. That might sound like a long time, but in cosmic terms, that's basically yesterday. Our own Milky Way took over 13 billion years to become what it is today. These galaxies had somehow packed in the same kind of mass in a fraction of the time. Astronomer Mike Boylan-Colchin from the University of Texas at Austin published a study in Nature Astronomy that stopped the entire field cold. He found that 6 of the most massive early galaxy candidates Webb had identified were so big, so early, that they fundamentally could not be explained by the standard model. And the math behind why is staggering. For a galaxy to form that fast and that massive, it would need to be converting nearly 100% of all available gas into stars. 100%. Scientists typically see a maximum of 10%. Boylan-Colchin said it plainly. If the masses are right, then we are in uncharted territory. We'll require something very new about galaxy formation or a modification to cosmology. And get this, one of the 6 galaxies appeared to be more massive than the entire Milky Way, despite the fact that our galaxy had billions more years to grow. Now, to be fair, scientists have since found that some of these impossible galaxies weren't quite as massive as they first appeared. Webb later revealed that some of the extreme brightness was coming not from trillions of stars, but from supermassive black holes at their centers, gorging on gas so violently that they were outshining entire galaxies. And when you subtract that extra glow, the galaxies beneath are more in line with predictions. But here's the catch. Even after accounting for all of that, Webb is still finding roughly twice as many massive early galaxies as the standard model predicts. The universe still has twice as many of them as it should. The problem got smaller, but it didn't go away. And speaking of those black holes, let's talk about the little red dots, because this is where things go from surprising to genuinely bizarre. Webb kept spotting these tiny, faint, deep red specks scattered across its images of the early universe. Scientists called them little red dots, LRDs, because, well, that's literally what they looked like, tiny little red dots. No one knew what they were. At first, people assumed they were just very distant, very small galaxies. Then, the University of Copenhagen published a study in Nature in January 2026, and everything changed. Those red dots? They're not galaxies, or at least in no way scientists had seen before.
They're young, supermassive black holes, each one 100 times less massive than previously believed, wrapped inside a dense, hot cocoon of gas they're actively consuming. The black holes are so young and so buried in gas that no telescope before Webb could even see them. The gas they're eating gets superheated, and that heat radiates outward through the cocoon, glowing red by the time it reaches us. That unique red signature is exactly what Webb was built to detect. Professor Durach Watson, who led the study, described it this way: the little red dots are essentially baby supermassive black holes caught in the act of being born, a phase of cosmic development so early and so brief that it had never been directly observed before. They could finally answer one of the oldest questions in astrophysics: where do the universe's supermassive black holes come from? They've always been there in the centers of galaxies, but nobody could explain how they got so big so fast. Now, thanks to Webb and those tiny red dots, we might have our answer. And as if that wasn't enough, Webb also found a galaxy named Virgil, as it appeared just 800 million years after the Big Bang. Totally unremarkable in visible light, normal looking, nothing special. But the moment astronomers looked at it in infrared, it transformed. Hidden inside was a supermassive black hole consuming material at a rate far exceeding expectations. Its mass was far larger than its host galaxy should have been able to support.
Regents Professor George Reich at the University of Arizona put it as plainly as any scientist in recent memory. JWST has shown that our ideas about how supermassive black holes formed were pretty much completely wrong. It looks like the black holes actually get ahead of the galaxies in a lot of cases. Pretty much completely wrong. That's a Nobel-caliber scientist talking about the textbooks that taught an entire generation of astronomers. Now let's get into the thing that's actually keeping physicists up at night. Because all of those galaxies and red dots and black holes, they're wild, but the Hubble tension is the one that has scientists genuinely rattled. Here's the deal. The universe is expanding. Everything is flying away from everything else at a measurable rate. Scientists call this rate the Hubble constant, and there are two main ways to measure it. Method 1, look at the early universe. Use the faint glow of radiation left over from the Big Bang, called the cosmic microwave background, and calculate what the expansion rate should be based on how the universe started. That gives you a number of about 67 to 68 kilometers per second per megaparsec. Method 2, look at the universe right now. Use pulsating stars called Cepheid variables and exploding stars called Type 1a supernovae to measure how fast nearby galaxies are flying away from us. That gives you a number closer to 73 to 74 kilometers per second per megaparsec. Those two numbers should match. They don't. And here's why that's not just a minor bookkeeping error. The gap between 67 and 73 might not look huge, but when you're measuring the expansion rate of the entire universe and your two most precise methods can't agree by an amount that keeps getting bigger the more precisely you measure, that means one of two things. Either both measurements have some kind of error, or the standard model of cosmology is missing something fundamental about how the universe works. Nobel laureate Adam Rees, the man who won the 2011 Nobel Prize in physics for discovering that the universe's expansion is accelerating, has spent years trying to figure out which one it is, and he had Webb do the largest study ever conducted on this question, using over 2 years of telescope data. The result was published in late 2024 in the Astrophysical Journal. Webb confirmed Hubble's measurements. Both telescopes agree. The measurements are not wrong, which means the standard model is. Rees said it himself. The discrepancy between the observed expansion rate of the universe and the predictions of the standard model suggests that our understanding of the universe may be incomplete. With 2 NASA flagship telescopes now confirming each other's findings, we must take this problem very seriously. And at a recent panel, he went even further. Something fishy is going on in the universe today, and we don't know what it is yet.
a Nobel Prize winner calling the entire model of the universe fishy because the maths doesn't add up. And now he has two of the most powerful space telescopes in history backing him up. And look, because Webb apparently decided that breaking cosmology wasn't enough, it also found a black hole the size of 10 million suns that is literally running away. Yeah, in early 2025, Yale astronomer Peter Van Dokkum published a paper describing a galaxy imaged by Webb that had a bright contrail shooting out of it, 200,000 light-years long. That's twice the diameter of the Milky Way, just a streak of compressed glowing stars left behind like a cosmic skid mark. The only thing that makes sense as an explanation, a runaway supermassive black hole, 10 million times the mass of the Sun, moving at nearly 1,000 kilometers per second, about 2.2 million miles per hour, after being ejected from a galaxy collision. This was theoretical for decades. Scientists suspected runaway black holes existed. Now Webb has seen the contrail they leave behind. 10 million solar masses rocketing through the universe at 2.2 million miles per hour. If that thing ever passes near a star system, those stars just get eaten. And then, because Webb apparently decided that breaking cosmology wasn't enough, it also found a weirdest planet ever found, officially named PSR J2322-2650b. It's a Jupiter-sized planet orbiting a neutron star, a city-sized dead star that spins dozens of times per second. The planet's atmosphere has no water, no methane, no carbon dioxide, the things you'd normally expect. Instead, it's packed with molecular carbon, and under the extreme pressures inside the planet, scientists believe that carbon might be crystallizing, compressing, forming diamonds. Deep inside this planet, it may literally be raining diamonds. University of Chicago astrophysicist Michael Zhang, who led the study, said it plainly: "It's very hard to imagine how you get this extremely carbon-enriched composition. How this planet even formed is, at the moment, completely unknown."
So here's the question you're probably asking. What does all this actually mean for regular people who aren't astrophysicists? It means the rulebook is being rewritten in real time. The standard model of cosmology, called lambda cold dark matter, or LCDM, is the framework that cosmologists built over decades to explain everything: how the universe began, how galaxies formed, how matter organized itself, why the universe is expanding. It's been the foundation of astrophysics since the late 1990s. And right now, within a span of about 3 years, the James Webb Space Telescope has found galaxies too big for it, black holes that formed too early for it, an expansion rate that doesn't match it, red dots it never predicted, a runaway black hole it only theorized, and a diamond planet it has no explanation for. Some of those findings will have more mundane explanations. Science always course corrects. But the core tension, the fact that the universe is expanding faster than the model says it should, that one isn't going away. It's getting confirmed more precisely every year. And the more precise the confirmation, the bigger the problem. Over 1,000 published papers have attempted to explain the Hubble tension. Over 1,000! And as University of Chicago professor Wendy Friedman, herself one of the world's leading experts on this, put it, astrophysicists have been trying to come up with a theory that would have explained different rates of expansion as the universe ages. It's just turned out to be extraordinarily difficult to do. What's potentially coming next is a new chapter in physics. Maybe dark energy, the mysterious force driving the universe's acceleration, isn't constant. Maybe it changes over time. Maybe there are particles or forces we've never detected that influence how the universe expands. Maybe the Big Bang itself was different from what we've modeled. Maybe all of the above. Adam Rees said it best: "Perhaps we're at the beginning of a new chapter in science. The universe is telling us something. We just have to listen and be willing to challenge everything we thought we knew."
a Nobel Prize winner telling us to challenge everything we thought we knew, because a $10 billion telescope pointed at the darkest corners of space found things that the smartest people on the planet cannot yet explain. If this video blew your mind, and honestly it should have, hit that like button right now. And if you want more deep dives into the stories that actually matter, science, history, geopolitics, the things the algorithm buries, subscribe. The universe has been keeping secrets for 13.8 billion years. We're just now starting to catch it. Don't miss what comes next.